10. So now this session is handled by Dr. Silchar, Associate Professor, Department of Electrical Engineering, NIT Silchar. So before going to handling the session to him, I will give a brief introduction about him. So Dr. Silchar graduated in electrical engineering from Dibrugarh University, Assam in 1993. He received his MTech from Power System from Indian Institute of Technology, Delhi in 2007, and he obtained his PhD in electrical engineering from National Institute of Technology in the year 2012. Before going to join NIT Silchar as a assistant professor, he worked in industry, so Northeastern Drilling and work for services company, Assam, from 1992, 92, and after that 93 he joined as RIG electrical engineer on ONGCL, Recapicol in Assam till 1997, and 1997 he joined as a lecturer in Jorat Engineering College. In 2000 he joined as a assistant professor in NIT Silchar. So he produced 8 PhD students and 10 are ongoing, and he published 47 international journals and 48 international conferences and 2 national conferences. And his research interests are power system control, application of subcomputing in engineering, power quality, distributed generation, power system, deregulation, automatic generation control, microgrid control, power electronics. So this is a brief introduction about Dr. Silchar, sir. So thank you, sir. Thank you for coming for this session. So, sir, I am handling this session to you. You please share your screen, sir. Before going to start, you please share your screen, sir. Thank you, sir.
Okay. Is it visible?
Yes, sir. Make it. Before going to make it is hide the top bottom bar, sir. Hide. Yes, sir. Now it is visible, sir. You can carry on, sir.
Yes.
Yes,
okay.
Sir.
Good morning to all of you. I thanks the organizer of this particular workshop for giving me the chance to deliver a lecture on a topic. I have welcome to all the participants of this course, and my topic I have chosen is this microgrid and virtual power plant opportunities and key issues. Actually, I have selected this topic based on some technical issues, say different structures of the microgrid and some issues related to virtual power plants. Okay, so this is not like a say presentation. This may help you or help the participants for going research in the area of microgrid as well as virtual power plant. Okay. So these are the outlines of my presentation. First, I shall introduce the renewable energies, then microgrid stakeholder, what is not a microgrid, why microgrid, classification of microgrid, hybrid microgrid definitions, various structures issue, concept of virtual power plant, virtual power plant definitions, structure of a virtual power plant and its components, energy management system, microgrid versus VPP, key issues of VPP, challenges to implementation of VPP, framework of VPP, opportunity, that is the operation procedure of CVP and TVP, then future trends, in this case, some research related issue will be discussed, then references. Okay. So, as you know that distributed generation technology encompasses a wide range of distributed energy resources. We will denote that one as a DER, and we will use DG term throughout this presentation. So as you know, DG refer to a variety of technologies that generate electricity at or near where it will be used. Okay, so means wherever it is generated, at that the same place it is used. Okay, uh, at emerging DG technology with associated local loads and the control unit is the microgrid. Just here, just this is one introduction to microgrid. Means DG, a microgrid incorporate DG technology along with the loads and the control. Okay, so microgrid can improve the efficiency through combined heat and power. We can denote that one as CSP. Increase overall transmission utilization, provide backup power and premium power, employ renewable energy such as PV, wind, and others, and decrease greenhouse gas emission. Now, always we are thinking about for a sustainable and resilience of energy system. Now, to obtain the sustainability in a energy system, we can apply microgrid technology. Now here another concept related near means same type of concept. This is virtual power plant concept. Now this is coming due to say the penetration of renewable distributed energy resources in the electricity market has shown significant growth, and this significant growth is due to concern like say carbonization of environment, pollution, clean energy supply, and demand requirements. Okay, so these are the factors which bring that renewable energy which are connected to the electricity market. The variable and unpredictable nature of output of renewable energy renewable distributed energy resources, like say solar PV. This is variable nature and unpredictable in nature, and affects the performance of the power system. So owing to the unknown input parameters of DG may add some grave complexity to the power system, such as serious voltage quality problem. Therefore, the increase in voltage in a restriction on the rising share of sustainable energy resources in the electricity market, posing numerous challenges. So these challenges we are not discussing here. Just say this power quality issue related things uh, are the challenges. To address these challenges, one way is to integration of distributed energy resources units into virtual power plant. Thus here we know that there is a thing, this is called virtual power plant. Now we'll introduce microgrid here. So there are large number of definitions of the microgrid in different literature, they give almost similar definitions. A microgrid is an aggregation of distributed generating unit, DG unit, distributed energy resources, DER, distributed energy storage, sensitive and non-sensitive load, a centralized or decentralized control system, and operating at a controllable subsystem which can operate in grid connected as well as in islanded mode. So here, the gist of this definition is that there is some uh, energy storage in this system. There is some distributed generator, and there is some load along with the control system. Along with the control system represents the microgrid. Now see in widely if you see that what are the stakeholders of a microgrid. So these are the essential stakeholder. If these are not available, you can any one of these not available, we can say this is not a microgrid. As for example, say this is consumer. Consumer means say these are loads. Then micro sources, different micro sources. Then energy supplier. This is energy supplier means this one our the supply system. So this is distributed system operator means this represents the control. So control micro sources, load, and the that our existing system. This represents the essential microgrid stakeholder. So along with this, there may be some optional stakeholder that may be controllable or shiftable loads, electric vehicle nowadays, then substation storage. These are also included in a microgrid. Now, what are the things? If you say microgrid, if we say microgrid, so uh, what is not a microgrid? Then if say this one absent, load is absent, you cannot say this is a microgrid. Absence of microchips, we cannot say this is a means microgrid. Absence of monitoring and control, this is also essential part. If it is absent, then we cannot say microgrid. Insufficient carbon credit. So in most of the some countries, many countries, this environmental protection is promoted by the provision of carbon credit. So that means this environmental, whether this system, this energy system protects the environment or not, if we consider, if these things are considered in a energy system comprising of these loads, micro sources, control, and this, along with this, then also, if this is also absent in some countries, it is not considered as microgrid. Okay. So now come to the classification of microgrid. According to the nature of power injection or withdrawal, a microgrid can be divided into three categories. Always we are telling that AC microgrid, DC microgrid, these are commonly uttered by the different students and others. DC microgrid, AC microgrid, or hybrid AC DC microgrid. Okay. Now see what is AC microgrid. That is part of the network consisting of DG units, energy storage, and load circuit can form a small isolated AC electric system. Okay, this is AC electric system. There is no DC bus here. There is a AC bus. All the micro sources are connected to the AC bus via interfacing converters. Then energy storage device also connected to the AC line, and loads are also connected sometimes from the the AC bus directly, or via some transformation devices. In most cases, AC microgrid system operations adopt the voltage and frequency standard applied in most conventional distribution systems. That means the voltage rating of this AC microgrid system is a standard conventional distribution system voltage. Now this is a picture of AC microgrid. Here different DG units are there, storage units are there, and mixed type of load. So nowadays DC loads are also increases in the power system. Now this LVAC here, this represents that distribution line, or you can say this is the bus. Here we have here it is shown two lines, but one line also sufficient to show it. There is a point of common coupling here where utility system is connected, and this microgrid, this portion also connected. So these whole things represent the AC microgrid. Here see, please look, there is no DC bus, only AC bus. This LV line, low voltage AC line, represents the AC bus. So here sensitive load, AC load, DC load, all are connected. So AC DG means like say wind energy conversion system, then DC DG like PV system are connected via this interfacing converter. So this interfacing converters are the power electronics converter. Uh, Power electronics converter, it converts DC to AC. Here AC to DC is connected, converted, ACT is converted to DC and given supply to this one. So energy storage system. So this is a bidirectional. Here there is power electronic interface is there. So with the help of this these energy storage units are charging sometimes, and sometimes it delivers power to the grid. So this is AC microgrid. Now come to the DC microgrid. Here part of the network consisting of DG units, energy storage system, load circuits can form a small isolated DC electric power system, which is nothing but DC microgrid. So here this is utility system. So it can supply power, or this system can supply power to the utility. This is your microgrid system. So this is the low voltage DC line. So then low voltage DC line, this represents the bus, DC bus. Now there is no AC bus here. There is no AC bus. All the generators, say wind energy conversion system, PV system, AC, all are connected to this. Similarly, that storage system also connected here, can also be connected via DC to DC converter, and loads are also connected. Say this is, since this is DC bus, so from that AC loads are supplied via this rectifier power electronics interface. Then DC loads can be directly supplied, or it is a voltage setting is not same. This DC is converted to DC load, DC via power electronics. So this is DC microgrid. Now come to the hybrid AC DC microgrid. Hybrid AC DC microgrid is a microgrid that contains both AC DC power sources and AC DC load. This hybrid AC DC microgrid considered to be most possible future distribution and transmission system. So this is completely new area of research, hybrid AC/DC microgrid. Though some of the works already done in AC/DC microgrid, but still there is many scopes for research. Now come to the structure of AC/DC microgrid is hybrid AC/DC microgrid. So hybrid term is there. So that means there may be AC and DC sources, all are connected. AC/DC load, all can be connected, means supply. So depending on how these sources and load are connected to the system and how AC and DC buses are configured, the structure of hybrid AC-DC microgrid can be classified into AC coupled microgrid, DC coupled microgrid, AC-DC coupled microgrid. So let us see what are they, AC-DC, AC coupled microgrid. So this is like our AC microgrid. Here there is one AC bus and AC DG, DC DG and AC DG. DC DG like PV, AC DG like wind energy conversion system, storage element, or all are connected to the AC bus via this interfacing converter. So these are the converters, power electronic converters. Here this is we use one bidirectional converter. Sometimes the storage system take power from the AC bus and sometimes it's supplied to the AC bus. So directly AC load can be supplied from here, uh, and if there is some DC load that can also be supplied from via this power AC-DC converter. So this structure is commonly used when dominant generation sources in the microgrid produce grid level AC voltage directly, such as diesel generator. This is one source, micro source. We can connect this one to the microgrid. But there is some issue, that environmental issue. Now say my major generations are this type of generation. In this case, AC microgrid is preferred. Now come to this DC coupled microgrid. In DC coupled microgrid, uh, here all the energy storage and the power source generators, that may be DC distributed generation or AC distributed generators, that are connected to DC bus, not the AC bus. Okay, so this is a power electronics converter, as I told that it converts DC to DC. So it is very important that this DC, whatever DC generators, like this is most commonly used DC generator. This is PV system. That output of the PV is variable in nature, intermittent in nature. We have to control. We have to control and make it a fixed DC. So by controlling this, controlling this DC converter, we can make it fixed. Similarly, AC distributed generation or generators are connected via AC-DC converter. So AC, whatever generated, is converted to DC and it is connected to DC. Okay. Now, this microgrid system, sometimes it is required to connect with the utility grid. So, we are not connecting, means in DC coupled microgrid, it is not directly connected to the DC bus via some transformation, but it is connected to AC bus. So, there is another bus here, this is called AC bus, where distributed generation or generators storage elements are not connected. Okay, only bus is there, so utility grid is connected to this. Now there must be, sometimes it is required to supply power from these distributed generators, these micro sources, to the grid. So to do this, again whatever DC here, that should be converted to AC. So this is done by DC to AC converter. Now here, sometimes it is required to take power or receive power from the utility grid. So it is already connected to AC bus, then this will be supplied Here there are some loads also there, energy storage elements should be searched. Then via this AC to DC converter, this is a bidirectional converter. We can represent this one, say interfacing converter. It is supplied to this here. Okay. Now DC loads are supplied directly from the DC bus, and AC loads can be supplied from either AC bus or say DC bus via this power electronic converter. Here DG and AC, that is distributed generators and storage energies systems, are connected to the common DC bus. Okay. Now come to this AC-DC couple microgrid. Here in earlier DC couple microgrid, only distributed generators are connected to the DC bus, but here no. Here both buses are, these sources can be connected to the both bus, DC bus and AC bus. Okay, so this is DC bus, DC, DG, AC, DG storage elements are connected via this interfacing converter. Then here there is one interlinking converter. This is just like function of that one is same as the DC couple microgrid, hybrid DC couple microgrid, but here it is renamed as interlinking converter. It interlinks between the DC bus and AC bus. Okay. Now here there is AC distributed generators. It need to connect to AC bus. Sometimes it is AC generated. It is converted to DC and AC. So here we can control. We can make fixed frequency and voltage can be controlled with the help of this. Okay. This is DC DG. So this is also connected via DC to AC. Now storage elements are connected via bidirectional converter. AC load can be connected from AC bus and DC bus both. But if you connect AC load from DC bus, then this converter is required. So here also, based on the voltage level of the load, we have to transform this one to load voltage. This is AC-DC couple microgrid. So this is just introduction to microgrid. Okay. Now come to the next concept, that is virtual power plant. Okay. It is denoted by VPP. Okay. A VPP. Now we should know what is actually it. VPP is a modular design entity based on software communication technology. This term is very modular design entity. This is entity based on software communication technology. Okay, so here it is just communication and software, information technology, communication technology. Based on this, one system is designed, okay, which effectively integrate this VPP effectively integrates, organizes, and manages decentralized generation, storage, and consumption through a smart energy management system. Okay. Now, function of this that this is a entity based on information technology, communication technology, which efficiently integrate, organizes, manages decentralized generation, storage, and consumption. This is also their consumption, means this loads and other things, everything, through a smart energy management system. Okay, the energy management system has the ability to risk aversion. Okay, so and uh, compensate the dropout of DER in real time, and show robustness to the variability of DER output. So energy management system has ability to risk aversion, means it eliminates that the risks whatever seen in energy system, and to compensate the dropout of DER in real time and show robustness to the variability of DER output. Okay? A VPP supports the coordination of generation and consumption. So that means whatever generated and consumption, it make balance. Balance means whatever generated, that will be consumed. It is like with a high degree of accuracy and facilitate the storage of energy. So in this case, so if say consumption is less, that can be storage in storage system, energy storage system. Hence, there is a huge opportunity for the virtual power plant to connect the operational technology with communication technology, and also with external data assets, thereby collecting and forecasting data from the dispersed unit. Okay? So again, what even huge opportunity for with connect the operational technologies whatever available with communication technology and also with external data assets, thereby collecting the forecasting data from dispersed unit. Moreover, VPP will be able to have deep insight into the data. That means it will really means handle a deep, large data, offer better and faster decision, and real-time action for performance improvement. Now, there are large number of definitions of VPP. All of them agree on the fact that the concept of VPP is a collection of dispersed, heterogeneous, distributed generation unit of various technology, of various that function as a unique power plant with the capability of controlling and coordinating the integrated units in order to maintain optimum power flow among these units and acquire better operational ability of the system. Now, I have studied this paper number 11, is reference 11. So, according to him, a VPP is a set of aggregated distributed energy resource unit that can be managed. That is, it is a set of aggregated DER unit that can be managed and coordinated from a central utility and connected either to a distribution network or a transmission network, able to contribute and participate in wholesale electricity market. This is very important. It is able to participate in wholesale electricity market. Okay, it is a set of aggregated DER that can be managed and coordinated from central unit, connected either to a distribution network or transmission network, able to contribute and participate in the wholesale electricity market, providing ancillary services to distribution system operator DSOs and transmission system operators. Now, this is structure of a virtual power plant. The simple structure obtained in reference 12. Here, these are the energy storage system, renewable energy system, CSP, or like this, micro sources, all are there. So these are managed by this entity, virtual power plant, VPP, And here loads, this consumption of loads also managed, everything are managed, loads, that generation of this storage, everything will be managed by this entity virtual power plant. And it manages the market also, it manages the market also. So there must be market. So this main difference, later on we will see what is the difference between microgrid and VPP. Here say there must be a market. Always there should be a market in the VPP. So other things, and this energy storage, DGs, storage, SEs, these are always there along with the loads. Now see what are the components of a VPP. Okay, an ideal VPP system is composed of three components, mainly three components. Ideal. So DG units, energy storage component, information and communication technology. This is very important. Information and communication technology. This is for ideal VPP. Here DG units all there, energy storage are there, information and communication technologies are there. Now we'll see what are the DGs used here, energy storage components here, what are the information technologies, and what are the function, what is the function of each unit, okay, DG. And the application of DG in the power sector have enormously increased due to, so they are small scale power generation and storage units located close small scale power generation and storage unit located close to the customer. Okay, so there is no transmission cost to supply customer. Okay, so the deployment of DGs reduces transmission network losses. So it will reduce the transmission losses. Then they can improve the viability of grid and quality of power by these DGs. They can do this, they can improve the viability of the grid and the quality of the power. So now energy management system, here energy management system, energy storage elements in VPP. So ESC plays a vital role in VPP functioning, especially in case of RES such as wind turbine generators, PV system, because they depends on weather condition and their output is greatly uncertain and variable. So this type of sources, this wind turbine, PV system, outputs of this depends upon the weather condition and it is uncertain. The energy storage system provides a smart way of energy storage that captures and stores solar and wind power and deliver it when it is needed. Okay? So there must be one energy storage system in VPP. So it will provide a smart way of energy storage. That means it will store when this sufficient power output from the wind turbine and PV system. Then when required, it can supply. It can supply. When required, it can supply. In this way, it balances the supply and demand requirement. So example of energy storage are hydraulic pump energy storage, compressor energy storage system, flywheel energy storage system, battery energy storage system, supercapacitor energy storage system. So these are some examples of the energy storage system. Now ICT, that is information and communication technologies. ICTs are playing a decisive role in energy management system. They manage all other elements of the VP in bidirectional way. So all other element in VP in a bidirectional way. Sometimes they will they will supply the information. It will via ICT will supply the information. Sometimes collect the information. This is a bidirectional system. It means it communicates. Communication is bidirectional. ICT are used to receive data from dispersed areas, storage element, and consumption unit. So they are also responsible for receiving data from these units, DG units, storage element, loads, consumers, from consumers. They ensure coordination of smooth flow of energy among the VP component. So it will ensure ICT, information and communication technology will ensures the coordination and smooth flow of energy among VP components. So this is just one example. Nowadays, many ICTs are used. So one example, say supervisory control, data acquisition system, and direct digital control. These are some ICTs. So most of the research are going on to develop ICTs for VPP. Now, energy management system. Here, the purpose of is energy management system is to accomplish this. Number one, to reduce energy production costs, to reduce power losses in distribution and transmission network, that is to reduce the power loss, to reduce the production cost, to reduce greenhouse effect, to reduce greenhouse effect, to increase profit margin of the energy, then to enhance energy quality. So this is very important, this energy quality of the energy, to increase the profit margin, to reduce greenhouse effect, to reduce power losses, to reduce uh, cost of energy production, to reduce cost of energy production, reduce power loss, reduce greenhouse gas, increase profit margin, enhance quality. So these are the main purpose of energy management system. So energy management system is the technological core and key elements of virtual power plant, establishing a robust and sustainable energy data management system. So how it do it? So this is a energy management system data monitoring and demonstration. This VPP, this is one of the energy management, this component of VPP. So they collect the power plant information. What are the sources available? What are the storage capacity, storage element available? What are the capacity? What is the capacity? Then operator specification, everything. That power plant information, that all data will be collected by this energy management system. Now, power prediction, since output of the renewable energy system, system are unpredictable. So this prediction also, prediction of this one can also be managed by energy management system for say particularly wind, solar, and like this. Now it will study the market, this market data. So what is the market price? What is the contract agreement? what are the power balancing contact, etc., are monitored by this energy management system. Now come to the load side, uses data. So what is the grid uses? Means what are the requirement of the grid? How much can be supplied from the grid? Then load forecast for the next few days. What will be the load? Everything can be done by this energy management system. Purchase contact. This is also done by this. So it is EMS is capable of collecting, storing, analyzing data. That is collecting, storing, analyzing data from dispersed remote monitoring devices. So data from dispersed remote monitoring devices in order to calculate the optimum operating schedule or operation schedule for electricity producer and consumer. So it will collect data, store data, analyze data from these remote monitoring devices. It will collect from diverse remote monitoring devices in order to calculate optimum schedule. Okay? So a VPP adopt the application of smart energy system. Now here say it will collect data, store data, analyze data, send data to the producer, consumer, collect data from consumer. Everything is done by this energy management system. So that's why you can say this is a smart energy management system to coordinate, communicate, and control all the activity taking place internally as well as externally. The key responsibilities of EMS are forecasting of the DR units, output power, that is what will be the output power of these distributed energy resources for next few days, forecasting of the controllable loads, power flow coordination among the VP components, management of DG units, and management of storage and consumption units. Now that was say introduction to VP and microgrid. Now people are seeing that what is the difference between that is VP, what is similarity, what are the similarities, what are the main differences. So VPP is a cluster of DERs, okay, which is collectively operated by a central control unit. This central control unit, very important. It is a cluster of DERs which is collectively operated by a central utility. So unlike VPP, a microgrid tends to be inward looking and static than VPP. So it is just like at this point of time, it is, we can say that inward looking. So this is limited to a particular place, limited to a particular customer or like that, and static than VPP. Okay, a VPP can only be created. A VPP can only be created if there is a market to sell power and services, whereas sell power and services, and whereas microgrid can be created anywhere and is not as dependent on the market structure. That means VPP is created if there is a market to sell power and its services, whereas microgrid can be created anywhere. Okay, created only created if there is a market. Created anywhere, it is not dependent on market structure. So there is no relation to market structure as far as microgrid is concerned. If we concern with VPP, there must be a market to sell power, and services, that ancillary services, whatever required to the power system, that can be supplied by the PPP. Okay? A microgrid can be disconnected from the main grid. This is also one thing that we know, that a microgrid can be islanded operating mode or say grid connected operating mode. We can use in any form, grid connected mode or islanded mode. But VPP cannot be. So VPP must be connected to this utility system continuously. Okay? However, once a microgrid start to sell its service, such as demand response, then it becomes VPP. So, however, once microgrid starts to sell its services, such as demand response, so this demand response, nothing but the demand side management. So that demand side management is can be done by the VPP. Can be done by the VPP or can be done by the microgrid side also, this from microgrid also. Now if you go from this, say there is a microgrid structure, from the structure it can such that can be managed, then we can say this is a VPP. Okay, so a VPP can replace a conventional power plant while providing higher efficiency and more flexibility. Although microgrid and VPP appear to be similar concept, there are a number of distinct differences. First one, the locality. In a microgrid, DERs, distributed energy resources, are located within the same local distribution network. So this locality is important. Say in microgrid, these are within the same local distribution network. And their main aim, they aim to satisfy primarily local demand. They are to supply the local demand only. In a VPP, DRs are not necessarily located at the same local network. Okay, but that local network may also be there, local network as well as that global network also means maybe there in a VPP, means not necessarily located on local network, and they are coordinated over a wide geographical area. That this geographical area is important, means there may be 2-3 areas that may cover by VPP, but a microgrid is within the local distribution network only. The VPP aggregated production participates in traditional trading in normal energy market. So, though it may be located in local as well as global, then we can say, but it will participate in the electricity market. Now, size. The installed capacity of microgrid is typically relatively small, from few kilowatts to several megawatts. Okay, but while VPP's power rating can be much larger. Consumer interest, a microgrid focuses on the satisfaction of local consumption, while a VPP deal with consumption only at a flexible resource that participate in the aggregate power trading. So microgrid focuses on satisfaction of the local consumption on local consumers, while VPP deal with consumption only, as a flexible resource that participate in aggregate power trading. Now, what are the key purpose of VPP? So the key purpose of VPPs are to provide the following opportunities to participating partners. Okay? So energy trading, they provide new ways and economically viable energy trading opportunities to distributed generator owners in the competitive wholesale electricity market. Okay? And network services, they provide system support facilitation services to transmission and distribution system operator. They will provide network support to the distribution system and distribution system, DSO and the TSO. Okay? Balancing services, they balance production and consumption demand, utilizing multiple markets simultaneously in real time. This results in economic, technical, and environmental benefits for all participating partners. Okay? Optimizing. Optimization of production and consumption inside the VP itself. This is also one of the key purpose. Now, what are the challenges to the implementation of a VPP? And the challenges faced by VP can be classified into 4 categories. Number 1, technical categories. This is technical categories. Then environmental categories, commercial categories, then regulatory categories. So everything should be maintained. Say technical categories. In the technical categories, technical issues of the distributed energy sources, technical issues of the cyber security, technical issues of the supply system, everything. Maintenance, everything, generator failure, everything should be considered in technical challenges. Okay. In case of commercial, they look into the market structure, market force, market price, energy price, everything are look into, means the comprise these commercial challenges. Okay. Now regulatory challenges, some regulatory regulations must be developed. Regulatory policies should be developed for future power energy system. So there must be some regulatory bodies who will decide. In VP, this will decide these things. Now, environmental issue, dispatchable technology. What are the technologies used here? So, by using this technology, whether environmental issues are considered or not, that should also be a challenge. Okay. Now, see what are they? The technical issues or technical challenges. These are related to voltage drop, unplanned outage, system capacity, transmission and distribution network operator. These are related to voltage drop, unplanned outage, system capacity, transmission and distribution network operators. To achieve optimum results, that is without a voltage drop, without an outage, etc., the transmission and distribution network operators should deal optimally. This DSO and TSO should deal optimally with power network. Deal optimally. So everything should be considered. Data will be collected from the DERs, whether available, when available, everything will be considered. and based on this, optimum operating schedule will be considered. So whether these things are there or not, so in a VPP, everything should be managed optimally. Now, quality of the power quality or power profile, reducing transmission losses, enhancing distribution network capabilities may lead to reliable and stable operation of transmission system network, ensuring non-stop supply of power to active users without interruption. So these challenges, say technical challenge, VP should operate in such a way that it should maintain the power quality, proper power profile, it should reduce the transmission losses, enhancing distribution network capability, so that uninterrupted power can be supplied to the participating consumers or active consumers. Okay. So now what are the regulatory challenges? Owing to the lack of obvious gov regulation, it is imperative to formulate and develop long-term truthful government policies and appropriate regulation in order to support and facilitate small-scale participants in the liberal electricity market. So it is imperative to formulate, develop long-term gov policies and appropriate regulation in order to support and facilitate small-scale participants. Now come to the environmental issues, environmental challenges. These are actually this environment dispatchable technology related. These challenges are related to dispatchable technology related such as wind turbines. When we integrate wind turbine or say DGs means diesel generators or like that, we integrate such kind of technologies run by fossil fuels also have a notable effect on the environment. These challenges are basically associated with fossil fuels technologies currently operating in power market, which can have adverse impact on environment. They can also create a notable greenhouse effect and hence damage the environment. Thereby, it is essential to assess every operating technology implementation carefully. So challenges to the implementation of VP, what are the commercial? Now come to the market. Commercial challenges are mainly related to market structure, market forces, and market prices. So new commercial management method need to be implemented to manage and support small-scale energy producer in the distribution network and minimize their costs associated with network maintenance and operation. Okay. So new commercial management methods should be implemented so that network maintenance and operation costs will be minimized, distribution losses will be minimized, etc. etc. Incentive strategies need to be implemented in order to reward renewable DG producers. Currently, market structures, pricing strategies are based on a complex mechanism. Market accessibility mechanisms should be made simple, easy, and affordable for maximum participation. Now come to this framework of virtual power plant. VPP aim at integrating different sort of DERs into a oh ये पावर देखो तो इधर पावर नहीं पावर है कि नहीं हाँ? No, no. Please wait. Oh. No? Oh, this coming. Oh. Please.
Okay.
There is
Okay,
a
sir.
power problem, okay?
Okay, no issue, sir. Take your time.
Okay. This coming. Oh, okay, it is coming. Running low. Power is there. Okay, sorry to interrupt. There is power problem in this. Okay. Okay. It's coming. Coming. Okay. This way. Okay. I am very sorry. Laptop power some problem is there. Okay, it is coming.
Okay, sir. No issue. Please continue.
Okay.
Sir.
Okay. Let me see. Okay, it is coming. Okay, no problem. Charging, no? Okay, after a break, there is a power issue, so sorry for that. So now come to this framework of the VPP. Now VPP aim at integrating different sort of DERs into a coordinated operational entity. So it is into a DERs are integrating into a coordinated operational entity, which could be competitively participate in the electricity market. So based on the characteristics of integrated energy resources, some key operation features, the framework of VPP could be divided vertically into two main parts. Commercial VPP, we will denote this one as CVPP, and technical VPP. So TVPP. Okay. So this commercial VPP look after this CVP services includes optimization of context, wholesale trading in markets, management in trade portfolio, system balancing services. So technical VPP, TVPP services include voltage profile control, management of local network, realization of ancillary services, and asset monitoring. Now see how this CPP framework and its operation. CVPP focuses on economic profit obtained from electricity market. C means commercial. So it is always this commercial is related to electricity market. For profit maximization, the framework of CVPP could be expressed as a flexible profile of DER's investment. So flexible profile of DER investment which is not only required a precise marginal cost assessment of internal energy resources, but also depends on rational evaluation of external electricity market structure. So, thing is that CVP will collect the data, then optimum scheduling of the collect the data of the DERs, optimum scheduling of the done that one. So economic scheduling also done, plus including a profit for maximization of the maximization of the profit. It will go for economic scheduling. Then what are the data means other things will be considered. Now say marginal cost of areas could be neglected with in comparison with known areas, which guarantees the prior scheduling of areas in VP's power dispatch. That means that marginal cost of areas is and that areas like PV, wind turbine generator, these are neglected, could be neglected compared with known areas generators. So, however, the potential risks behind the volatility of areas may compromise the expected economic profit, which highlight the importance of reliable output forecast for the integrated areas during dispatch cycle. Moreover, a rational estimation of load demand and other participators' bidding strategy could serve as a foundation for CVP's optimized bidding strategy in electricity market. Now we'll see how this CVP operates. Means operating procedure. There is no standard hard and fast procedure for CVP, but here say this is our CVP, that is commercial virtual power plant, and this is technical virtual power plant. Now consider this one, CVP, commercial virtual power plant. It will collect economic parameters. It will collect economic parameters from DERs. So based on the proper estimation of integrated areas, these are integrated areas and known areas, economic parameters such as cost curve of this, forecast output of this PV, then wind turbines, etc. These are these are economic parameter, that is cost curve, forecast output. CVP determines the priority order of its internal energy resources. So there are large number of DERs here in the VPP, large number of DERs. So out of this, all datas of all DERs, here more number of DERs are there, datas of all DERs are available. Now, out of this available data, that economic parameter, that is cost curve, forecast output, everything will be are collected by the CVP. Okay? Now CVP collects and possesses electricity market intelligence. So electricity market intelligence, which includes not only the load demand but also historical information of other participators' bidding strategy. Now CVP, another function is that it will collect It will collect market intelligence via market intelligence, which not only load demand. What are the load demand in the that energy system? It will collect the data. Then similarly, bidding strategy of the participators. There are many participators. What are the strategy of this one, this one, this one? Everything will be collected by CVP, and it will collect and processes the electricity market intelligence. Okay, so after processing this data with this information, CVP formulates an optimized generation profile with an economic scheduling for each integrated energy. So it will see what is the load demand. CVP will see what is the load demand, what are the participators, what are the bidding strategy of different participators. All the data will be collected by the CVP, and it will decide which are the DERs will be used for for generation, for economic power generation, where there will be profit as well as collection of the generating cost of this. Okay, everything. So with this information, CVP formulates optimized generation profile and economic scheduling for its integrated energy storage. After that, VPP submit bidding strategy to ISO as a unique entity. So after that, it will again submit bidding strategy to ISO, independent system operator. They will look after this. Say after this, they will contact with the participator, market, etc. Okay. Then ISO collect the bidding information. This ISO collect the bidding information and conduct market clearing central dispatch. So ISO collect the bidding information and conduct market clearing, or say at what price it can give. It will conduct dispatch. That will be conduct market clearing or central dispatch. What will be the market clearing price? What will be the dispatch? It will be conducted by the ISO. Depending on the market clearing results, that is what are the accepted bid and market clearing price, CVP optimizes the internal scheduling profile. Again based on this, CVP optimizes the internal scheduling profile. So this will be bidding strategy submitted to the ISO. ISO is again compared with this and conduct a survey. What is the price of this, everything? Then again, CVP optimize internal scheduling. But at the same time, what are the say if there is some faults and other things are there in the DERs, that should also be taken care. So that are taken care by the TVPP. Okay. Now see, CVP submit the final generation profile of the DERs for power system for safety sake. So final will be obtained from here, and it will see for safety sake, generation profile will be submit the generation profile for power system for safety sake. If any technical violation discovered by this, ISO will see this one also. Then CVP should reschedule the generation profile and go through step 1 to 4 above. Again, until all safety regulations are satisfied. Okay. By the end of dispatch cycle, CPP settles account with ISO and conduct internal profit redistribution based on its resources, operating performance, and deviation punishment calculated by the TVP. Now, by the following, the above procedure, CVP manages to integrate different sort of DERs into a coordinated entity to participate in all form of electricity market, which not only relieves the difficulty of DER management, but also improve the utilization of RES in user side. Now come to the TVPP framework, aims to ensure the safety operation of VPP. So TV technical virtual power plant aims that the safety operation of VPP and providing real-time data of DER's operation status. Okay, it's ensured that whether VPP is safely, it will see that whether it is safely working, providing real-time data of DER's operation status. That is, that what are the real-time data of DER's, real-time data of this one will be supplied. So unlike CVP's profit seeking, actually CVP's main aim is to maximize profit, but TVP is not for profit. It will see TVP shares the same responsibility of ISO, which mainly focuses on execution of power scheduling. TVP mainly focuses on execution of power scheduling and performance of power balance. The operation procedure of TVPP, that TVPP collects technical parameters of integrated DERs which contain static technical information such as DER's RAM limit, capability limit, dynamic operation data, etc. Say mail function, operation status, output power, electricity storage, everything. These are the technical information. These technical informations are collected by TVPP. TVP submit overall technical parameter to ISO and receive related system safety regulation from ISO. So it will receive related safety regulation. It will receive safety regulation, implement the safety regulation during operation of DERs. Now, based on the economic profile determined by CVP and the system safety regulation provided by ISO, TVP conduct VP's security check. After everything, CVP had worked, then security checks are done, then TVP conduct VP security check and communicate with the CVP about necessary modification. If anything say wrong there, once security violation is detected by ISO, TVP react in time to ensure safety requirement and reschedules power commitment until all safety regulations are satisfied. So during execution of VPP's power commitment, TVP supervises the real-time operation status of all DERs to maintain internal power balance. This is also another function performed by this TVP. which could be achieved by altering controllable DR's output in accordance with earliest deviated output. By the end of dispatch cycle, TVPP calculates the next exact output of DRs and delivers the settled output to CVP for profit calculation and redistribution. Okay, now we are coming towards end. These are just technical things I had explained. Now, what are the research opportunity in hybrid AC-DC microgrid? Here I have considered hybrid AC-DC microgrid means this itself there is enough research opportunity in hybrid AC-DC couple microgrid. Now, first, while we are going for a research, we should see that what is this structure, what is this system, is there any new things, new improvement can be done in a existing system. So now say future AC-DC couple microgrid will have several DC and AC buses in different voltage level and maybe frequencies if there is high frequency link. So this is also say now what about the microgrids available here in AC-DC microgrid? In future there may be several voltage level of DC and AC buses, and that can also be possible. Or say in case of AC bus, there is only one frequency changes frequency voltage, AC voltage. So there may be high frequency link also. High frequency bus may also be there in a hybrid AC-DC bus. So as a result, DC bus voltage control, power balancing within DC bus, AC bus, grid load, and AC bus voltage and frequency control if necessary are the main power management challenges and objectives. Moreover, the operation of ILC interlinking converters connecting different DC and AC buses in different voltage level can be an interesting research topic. So ILC, I have seen few papers, research papers, many parallel ILCs are used, they are proposed. So in future research, if there is a more number of buses will be there. So research on ILC also one of the interesting topic. Now power quality issues. In future hybrid AC-DC microgrid with more interfacing power electronics from the DCs and ACs and the loads together, the increasing non-linear loads, power quality will be an important topic. Since we are using power electronics converters for all DCs and ACs and the loads, it increased the power quality problem. Now this power quality mitigation of power quality issue, power quality signals from the AC and this AC will be an important topic. With the increasing utilization of DG and AC, IFC interfacing converter, they can be properly controlled to help address the power quality issue. Now another thing is coming from this power quality issue. Now development of ancillary services such as flicker mitigation, unbalanced voltage compensation, harmonic compensation, power factor correction, etc. can be a good research direction in future microgrid. Now parallel operation of ILC and IFC. IFC and ILC are critical link. I told you that links between AC and DC bus in a hybrid microgrid, their control is the key for the power balance between AC and DC systems. ILC and IFC, interfacing converter, interlinking converter, will typically have parallel converters operating together. Therefore, parallel operation of this converter and their control strategies are an interesting topic. Now, communication system is also an important research in future, since there may be multiple links between the DC and AC buses at various locations. Now, in case of VP, now say in VP, mainly research in development of an innovative VP structure. So this is one. Then optimization technique, diverse optimization technique can be applied, and novel calculation algorithm. Now say innovative structure. Till now CVP and TVP is there. Now in future there may be another level of control, that may be some other control, internal IVC, that some other internal level control may be one of the research. So diverse optimization technique at present, VPP optimization focuses on internal energy dispatch and external market at present. Market participation. The optimization technique also concentrates on multi-objective and risk evaluation. However, the market competition between multiplayer deserves further investigation. Okay. Novel calculation method. So far, the convergence and computation speed of heuristic algorithms are obviously not suitable for realistic deployment of VPP. Future research may be the use of novel mathematical solution to improve the realistic applicability of VPP. So this microgrid structure, using that hybrid AC-DC coupled microgrid structure along with the information technology and communication technology will be another structure of this VP, and that will be also one of the important research area. So this is the last slide, I think. These are the references. Thank you. Any question from the audience?
No question. फोटो किसके लेके हो? हाँ सर, thank you very much, LC Saikya sir, for your valuable time. So most of our participants, they are very happy with your session. They are given the feedback as nice session, excellent session, informative session.
Okay. Okay, thank you.
Sir, wait, sir. Questions are there?
Any question?
Yeah. One participant from YouTube, they are asking, data to clouds, if energy from SPV has become half, how does the MG behaves?
So I could not means. Can you what question? I could not understand that question.
Sir, due to clouds, they are asking. For example, cloudy is there. Cloudy weather is there. If energy from SPV has become off, how does the MG behaves? Microgrid behaves.
Microgrid behaves.
Yeah.
Acha, microgrid actually that VPP is different thing. VPP, everything will be controlled by the CVP. That is commercial. That will be controlled by CVP. This is in case of VPP, means virtual power plant. But in case of microgrid, that communication technology actually that can be used, but here communication between the different entity different DERs, that is also one communication technology that can also be used. That will be, I think, future we can use in the microgrid also, between this communication between the DERs, control, and the everything. Okay.
Saike sir, you please stop your presentation.
Okay. Presentation, please wait. Okay.
Yeah, stop presentation. Yeah.
Okay.
So that's all for the questions, sir. If any further questions we will receive from the participants, we will send you through email.
Okay.
So the overall feedback I have gone through the YouTube. It was very fine, sir. Thank you very much for your valuable and informative session, sir. Thank you very much, sir.
Okay. Thank you. Thank you.
So the participants, that is the end of our 10th session. So afternoon there are two sessions, session 11 and 12. The session 11 was handled by Wasim Arif, Dr. Wasim Arif from NIT Silchar, and the session 13 is handled by Professor BK Roy, sir, Electrical Department, NIT Silchar. So you please join at 2 p.m. So that's all for now. Thank you very much.
Okay.